This is Felipe. He's working at Booking.com as a machine learning scientist. And he will today talk about how to use business metrics instead of traditional machine learning metrics for his machine learning models. So give him a warm welcome, Felipe.
Thank you. Great. Thank everyone for coming to my talk. Well, I'd like to introduce myself for people that don't know me. I'm a machine learning scientist at Booking.com, where I specialize in uplift modeling and causal machine learning. I work in the smart benefits team in Booking Insights pricing department. Before Booking, I was a PhD in Delft. For those that hasn't been there, it's a really nice city. I'm also co-organizing of the MLOps community in Amsterdam. So if you want to know more about it, please shout me out on LinkedIn or send me an email. We have every 2 months meetups focused on ML and MLOps. So the agenda for today is I'm going to cover 4 points for you. I'm going to talk about ML and business metrics and what are the problems with them. Then I'm going to give a brief introduction how you do offline evaluation and online evaluation, and some approaches that you can use, very simple approaches in machine learning for using these business metrics. And then I'm going to go over a practical use case at Booking.com that my team, we use uplift modeling. Before going through my first slides, I'm going to acknowledge in this conference we had 4 nice talks that you can also watch it later about on the same topics. So all around causal ML. So you can also follow this, and I really like those talks. So I'm gonna shout to these people there. Well, first let's start with the ML and business metrics. And there's 2 hard truths for you today as a data science or ML practitioner, and as well your stakeholders may have here. Is that most of the times ML practitioners, they care too much about ML metrics. And you have too many of them, right? So many times we are there trying to model our problems and we are just focused on those metrics. And suddenly we want to deploy our models and well, what actually our stakeholders care about are the business metrics. And what are those business metrics most of the times they're looking for are directly increasing their profits or long-term value in the customers. And well, and this can be directly increasing sales, conversion rates, or cutting costs, but also indirectly, where we want to increase higher customer satisfaction and finding the right product. And this is our role as an ML practitioner. We go over all these plots in a hyperparameter tuning, try to find out the best models, all using metrics like log loss, hyper precision, AUC, right? And what our stakeholders want us to go is to go over the business metric and find the best model if you have all these possibilities of these models based on the business metrics. How can we close this gap, right? So this is what I want to talk about in this talk. So for ML system model and system to succeed, we need to tie the performance of the ML system and the overall business metric. And how to do so? Well, sometimes it can be simple. Sorry about it. Examples, one of them here is add click-through rate prediction, where if we increase our precision in this system, this ML system, we may increase ad revenue, right? And another example, which is simple to tie, is fraud detection, where if you increase sometimes the precision of the fraud detection model, you might actually save costs to the business. And those are, well, you can actually map directly the ML metric and the business metric. Unfortunately, this is not for all ML systems and all ML problems. Here I'm showing an example for my problem. I'm showing you later in this presentation, where if you look to the ML metrics and the business metrics, they don't correlate that strongly. Especially for very strong ML metrics like log loss for classification, where in my case, it doesn't show that it's very high correlated to that model. This sucks, and we really want to also close this gap, right? And our stakeholders really want us to do this. So how we do evaluation using those business metrics? Typically, we want to observe these improvements in those business metrics, and in which to mirror what we call offline evaluation to the online evaluation. And at Booking, we do the of course with A/B testing. So typically, you have your baseline system that has been running production, and you want to test out a new model. So this is what we, and then we also have in some systems where we have the control traffic, where we use this most for the causal ML models, which is typically the problem we face when you try to measure some of these business metrics. All these three sets are what we call online evaluation. So we want to, if you deploy our model, we are preserving these metrics, right? But sometimes you actually can look at the offline evaluation and only look to these two first sets to derive what would be our results on these business metrics before deploying a new model. Well, given the set, we can answer questions, right? What would be the change in the business metrics if I deploy this new model? How much cost will this model save? If I compare with the model that is in production, or maybe if I control with the no traffic that has no model to it. How much increase in conversion I'm going to have, and how much increase in return investment. And unfortunately, some of these indirect profit metrics can't be measured in an offline manner, right? So increasing customer satisfaction, active customers, those metrics are not prone for this offline setup. Therefore, we actually need more robust or more efficient online evaluation, and for example, using contextual bandits. A nice paper from my colleagues at Booking is this one here from Europe in 2021. So if you want to know more about it, also take a read. And now I want to go over, well, how can we actually use this offline evaluation setup and using those offline evaluation setup to optimizing for our business metrics. Two simple techniques that I have been using this project is in early stopping hyperparameter tuning optimization. Most of the times, we only look to these two techniques by only the eyes of ML metrics, right? I want to give you a point of view, how can you do these techniques using business metrics as well. For those who don't know, the early stopping is typically where we try to train our models and we stop this model before we actually don't actually observe any improvement over some validation set, right? So this is the typical curves that we look. If you look to the ML metric or to the loss, then you stop it at some point that you don't see any improvement. This also can be your business metric, right? You can also stop your model training on this business metric at the point that we don't observe this improvement. So most of the times we don't do this, and this is something simple that can be done. So what would be the benefits for overall of the early stopping, right? You can generalize your new data, improve overfitting, and also save a lot of time and resources from you as a practitioner. And can be used in several families of models, right? So in neural networks, we see this in number of epochs, how many, the size of the data set you have. And in gradient boost machines, like HBM, this is the number of iterations and trees that you have in your model, right? So you might want to have simpler models based on your business metric. You don't need to go further if your business metric is not improving. One that is more, I like more, which is hyperparameter tuning optimization. And as again, here is actually we're trying to find the best combination of the hyperparameters in your models, right? And we do that still with the ML metric and not with the business metric. So, and just to point out that there are two simple techniques that we do it: grid search and random search, and those are techniques that we can find the business metrics as best model on business metrics on these sets. Now, these techniques can be inefficient for high dimensional spaces like trees or gradient boost machines where you have too many hyperparameters to try out, and you're not going to guarantee that you're going to find the optimal model doing your search. And well, the main problem of this with this grid search is that it neglects the prior evaluations. right, of your as you're searching. And one set of family of techniques that goes over trying to solve this problem is sequential model optimization. And first, starting with Bayesian optimization, where you have a hyperparameter that you're searching for, and you have a performance of your model for that specific hyperparameter, and on these prior optimizations, and then you can feed a new model over trying to find what would be your how would be your performance of your model for that specific hyperparameter. And then we use this prediction to find the new hyperparameters that you can search for. And then this performance, again, can be both a UML metric, but as well your business metrics that you're looking for, right? Now, what I found my promising is what we call the three-parser estimation, that we are using currently, and I'm going to go a bit deeper on this. So the idea of this is, instead of modeling what would be your performance of your model, giving some hyperparameters, you model what would be your hyperparameter and what if you find the performance of it. So you the pi, the x given I. And for doing this three-parser estimation go for two surrogate models. So you first look for trying to find the good group of hyperparameters, the good group of range of hyperparameters, and the bad group. So we're going to estimate these two groups instead of just two models instead of one. And how we define this is we need to find a threshold, what you define as a hyperparameter of your hyperparameter tuning, where you define what would be the good and the bad. And sampling new promising hyperparameters can be based on the expected improvement metric, which is the division of these two probabilities. Here in the visualization, how you typically do this, while you're searching for the best hyperparameters on the plot on the top, you see that as you search, you keep looking for the good group, right? So then you are able to find the range of your hyperparameter on this new group. This plot is not mine, so this is a plot made by criteria engineering, which I find very intuitive to understand this. And in this blog post really explain quite well these techniques. Given these two sets of techniques, I want to show how I use this in my practical use case. And here is uplift modeling at Booking.com. Uplift modeling aims to find what would be the most powerful impact that you have, or the causal impact of your treatment. Can be a promotion in this case, and the difference of this with and without that promotion. What we're looking at is to build two models, where one is actually try to predict what would be the conversion of this customer, given that we provide them the promotion, and what would be the conversion without the promotion. In this project, we use a little trick that we call retrospective estimation, where we convert this to a classification problem with just one model. Which means that instead of predicting the conversion, we go and predict the promotion probabilities, giving a customer, given that he's already going to convert. And if you want to know about this, take a look at the free lunch retrospective lift modeling for a paper that we have in RecC 2020 in my team. And how you provide this problem, how you evaluate this model in offline manner. We first look at your traffic for the treatment, which means that treatment where you give a promotion to everyone. This is typically done, and we saw a case here in this conference from Uber as well, that they also do the same, where you have a traffic of your customers that you always provide a promotion. And then you also have a traffic that you observe, which is the control. If you remember the two sets that I showed in the beginning of this talk, this is the left and the right, the first two left sets. And based on this, on the treatment that I already know which people that I should give promotion, I try to predict what would be the highest probability of I should give promotion to some of these customers. And I would pick some of these customers to give actually the promotion online. And this is where it comes the offline evaluation. So this is I'm looking at everyone that I have already provided a promotion, and I'm actually now selecting part of these people that you can think this as in a simulation as well, and I can compute this marginal return on investment or other business metrics that you care about. Just a quick, more like techno here is, well, for this example I'm showing is a data set of more than 30 million rows. We typically split this in timestamp manner, and we like LightBM, as I have been talking so many in this talk, so we go for a LightBM binary classifier, and I look for 6 hyperparameter tunings to find the best models of them. My experiments here is going to be on a random search where my hyperparameter tuning metric is going to be 3, the log loss, every precision, and business metric. And I go for a Bayesian optimization for TPE with 3 metrics. And the last one I want to try out is the full business metric, where I do early stopping on the business measure, but as well the hyperparameter tuning. All these experiments, we use 1,000 trials using Optuna library, which is a very nice Python library for hyperparameter tuning. If you have it used in your projects, I really recommend it. Very robust and can really scale on your projects. First, I want to look at the hyperparameter tuning results, specifically comparing here what would be for the ML metrics, what would be the impact of using Bayesian optimization versus random search, and what would expect that once we do hyperparameter tuning using TPE, we often find the best model earlier. And this means that instead of going for 1,000 trials, typically you really can go much shorter and might really save a lot of time rather than just do random search on your models, on the ML metric. What is more interesting is going for the business metric, right? Where if I go for a random search on the business metric, I would go to find the best model on very, very late. And typically having observing is that once you use some Bayesian optimization on the business metric, you can do it much earlier. This is, again, some results for this use case I'm showing that we have at Booking. So as a hyperparameter tuning using business metrics helps find this much easier, much earlier. All right. And now, how about the early stopping? Well, the early stopping goes, it's really finding the best model in the very beginning of your trials. And this scared me a little bit. When I looked at these models, I saw that the early stopping on the business metrics tend to bring simpler models with the best results on the business metrics doing the hyperparameter tuning. Now, looking at these results overall, right? It's not just looking of the hyperparameter tuning results, looking for the offline evaluation results that I talked to you about, is you get all this model, and on the y-axis you look at your business metric, what would be it, and the x-axis is the traffic, how much people you're willing to offer promotion. You see that these models are behaving quite similar, with the exception of the actually using full business, which is the early stopping and the hyperparameter tuning. What is more important is that if you look at the area under the business metric, we can summarize these models, the ones that are very close by, and it's hard to visualize. Where if you look at the TPE, which is the more the Bayesian optimization style, comes on top and after the random search. Why I put it on top? Because it helps us stop much earlier doing the training. So what would be here the take-home message for this talk, right? We saw that how important is to tie the business metric and the ML metric. We saw techniques that we can optimize machine learning models using business metrics, and hyperparameter tuning optimization, reusing random search is time-consuming, so TPE can speed up your hyperparameter tuning optimization. We also saw that the business metric helps to find terminated hyperparameter tuning earlier, and early stopping using business metric do not bring the best model always. What you can do next in your project, right? Well, you can use those techniques in your business problem, right? So I'm really curious to know if you also face the same problem. Do you also always have to deploy your model? Do you also see less improvement in the business metric, even with the best ML metric? Well, you can try out such more techniques. Pruning is very, very nice. I really want to go deeper in it at some time later on in my projects. And maybe you have two business metrics, and you can actually using hyperparameter optimization with multiple metrics. I'd like to thank the Smart Benefits team. So this project not be done without them. And thank you for listening. And if you have any questions.
Thank you, Felipe.